So today we're gonna continue talking about the this method, and then we're gonna move to the shell method, which is going to be the most two popular method that we use to find the volume of the solid of revolution. All right. Well, now it's 3:02 p.m. So we are still waiting for our friends to attend the class. So in the meantime, I am going to review this method that we just learned on Monday. So on Monday, we say that if we have a region R, so we can rotate the region R around the axis. And then after that, I am going to get a solid that's obtained by a rotation. And then we are going to find the volume of that solid by just uh, cut the solid, and then after that you're gonna see that your cross section is circle, and then you can use the area to be pi r square, and then after that you just plug in into the integration, and then that will be your formula for this method. uh, let's see the example that we just did last time. So example 184. So we have a region that I highlight in light blue. So if you look at the slide now, so you're gonna see that, hey, we have the region R that is highlighted in light blue. And then what I did last time is, well, I just rotate this region R around the x-axis, and then what I get, well, actually, I'm going to get this is region R, right? I am going to get the solid like that. This is going to be my solid that I get after I rotate the region R around the x-axis. And then after that, well, we need to find the volume. So for sure, if I cut the line like that, I mean, I cut the region like that. So every time I cut here, so I'm gonna get the circle. As you can see that the region is here, and then after you rotate it, so you're gonna get some solid like that. And then if you cut the vertical line, so you're gonna get the cross section to be your circle, and then after that you can use pi r square here in the integrand, and then you just need to figure out what is your radius. So your radius for this question is going to be x plus 1 square, which is the top line, minus the bottom line, which is x equal to 0. So that is why uh, your radius is going to be here, which is the top line, x plus 1 square. The bottom line going to be 0. And then that is your radius. And then you just plug it into the formula, and then you integrate from 0 to 2, because you start from x equal to 2 to x equal to 0. That is how we use this method to find the volume. Well, today we're gonna keep going, and then we can answer more questions, including the previous question in the chat now, because today we're gonna move our axis of rotation to something else. So you can see that what we learn on Monday is we learn the case that you have the region here, and the axis of rotation is just next to the region. In this case, this is the easy one, because you can rotate R, and then you don't have to be worried about the gap between the axis of rotation and the region. But today we're gonna look for the harder problems, and that will answer previous question. So let's wait 15 or 20 more minutes, and then you will see how we approach when the axis of rotation just move away from the region. All right. Well, I just keep talking because I'm waiting for more people now. So we have 27 people now. Okay, that's good. So we're gonna start now for the new content. So today start from page 26. We are going to look at this method again, but this time let's suppose that we are looking for the case that we have a gap between the region and the axis of rotation. So what should we do? So we're gonna start by the easiest one. Let's suppose that you have a region that I show you in the picture here. Suppose you have y equal to square root x, which is this line. And then you have y equal to x squared, which is the line that I just put the green color here. And the region between x squared and square root x. So I shade it here. So this is the region between them. I am going to rotate this thing about the x-axis. So what happened is I'm gonna get the solid like that, right? So I have this that I highlight in blue, right? And then I rotate about the x-axis, so I get the solid. However, so you can see that actually the inside here, this is actually a hole, because once you rotate it, so you're gonna miss something inside there, because you know this is a hole. So what we can do for this case, we're gonna just uh, compute the volume of the solid for the big one, and then we're gonna compute the volume of the solid of the small one, and then we subtract each other, and that will give us what we want. So the idea is we're gonna define something called inner radius and outer radius. So when we do uh, the case that we have the hole inside the solid, so we're gonna start by, hey, so this is the idea. So what we do is, since you have y equal to square root x here, right? So we're gonna rotate y equal to square root x, so we get the solid here first. Well, this is called solid number one. And then after that, we're gonna do one more time. So we're gonna just, but this time we're gonna do y equal to square root x, which is this curve. And then if I rotate about the x-axis, so I'm gonna get this solid, right? And then I have solid number two. And you can see that if I start from number one and then I subtract number two, so what I have left is going to be what we want on this picture, right? Well, this is going to be what we want after we rotate the region R about the x-axis. So it's just number one minus number two. Does it make sense? So that means the formula for this is going to be V equal to integrate from A to B. So you still use A to B, right, on both picture here. But when you do, you're gonna just do the pi r square. The first r gonna be the, let me show you here. So we're gonna call, look at the picture number one here. We're gonna call this thing uh, the radius here, we're gonna call this thing big R. This is called the outer radius. And for the picture number two, this is the small one. We're gonna call this thing the inner radius, because this is the inner one that it's gonna be the hole inside eventually. So we have outer radius and inner radius. So actually the formula is gonna be V equal to integrate from A to B pi r square. The r square, the big R is the outer radius, the x, minus integrate A to B pi small r mean inner radius, square dx. And then after that, you can group them together. It's going to be integrate from A to B pi big R square minus small r square dx, which is the same formula as I just showed you in the highlight in green here, pi fx square minus gx square dx. If you suppose that your outer function is fx, inner function is gx, so that's the formula you will get here. Actually, I am more familiar with the formula with the big R and small r, this is make more sense to me to memorize. So, but the whatever you can memorize whatever you want, but you have to know that the idea of this thing is you just use the outer radius and inner radius. Does it make sense? All right. This thing is called this method with the whole, or sometimes in some books they're gonna call watcher method. Well, actually, watcher method is more popular name compared to this with the whole, but you know, that is just your preference. All right, so we're gonna look at more examples about the this method with the whole inside, or that is what we call the watcher method. All right, so before looking at the example, so I want to mention that, well, you still can use the x or the y. It depends on uh, the axis you cut with respect to. So if you are doing a vertical line, if you are doing the vertical line, so it's going to be the x. If you are doing a horizontal line, it's going to be the y. So you can do whatever you want, but well, some, as I told you, some region it is easier to do the x, some region it is easier to do the y. It depends on you. Well, but keep in mind that if you plan to do this or watcher method, so what you have to do is you're gonna cut perpendicular to the axis of rotation, perpendicular to the axis of rotation. So the line that you cut, you're gonna cut perpendicular axis to the perpendicular, cut perpendicular to the axis of rotation. Okay, sounds good. So, well, let's put everything together and trying to do the example together. So this is the step if you want to memorize, but well, actually just get the base. Find the axis. You draw the vertical or horizontal line. It depends on the picture, but actually, if you want to use the method, watcher method or this method, you have to cut perpendicular to the axis of rotation. Well, if you cut parallel to the axis of rotation, that is going to be your shell method. We are going to learn in the next section. And then after that, you can find the outer and inner radius and just put it in the integral, and that's all. So, well, it looks hard when you look at the steps here because you have to do so many things. But well, if you understand the picture, the best friend in your chapter is going to be picture. As long as you can draw the picture, that will lead you to the solution for sure. So I feel like the hardest part for this chapter is drawing a picture for you because some of you just forgot how to draw the basic graph already. But well, if you get a graph, everything going to be easier because you can start from the picture and trying to go from there. All right, so let's start from the basic one. So let's say if I want to find the volume of the solid of revolution obtained by rotating this region about the x-axis. So I have the region that is an intersect of something below y equal to square root x and something above y equal to x squared. This is my region R. This is the one that we just discussed in the example. So we're gonna find the volume after you rotate this thing about the x-axis. So you can see that your V gonna be integrate. Well, let's think one more time. So when we do this thing, so you have to rotate about the x-axis and you're gonna get something like that, right? But you're gonna have a hole inside. This is your hole. This is going to be your hole. So actually use the washer method and your formula is gonna be integrate from A to B pi big R square minus small r square. So the big R gonna be the outer radius, the small r gonna be the inner radius. and then after that you have to figure out you want to use the x or the y. So for this example, so you can see that my axis of rotation is the x-axis. So I want to make it simple. So that means I'm going to just cut perpendicular to the x-axis. This is how I cut the region. And if I cut this region perpendicular to the axis, that means I use dx. Does it make sense? So I use dx. So what I need is I need the outer radius. What is going to be my outer radius? This is R radius, big R, not just the R in region. So I use the same notation, but you know it can be confusing. But hope you know that they are different. So the outer radius is going to be the one that you start from the axis of rotation, and then you just go to the outer graph, right? This is your R, big R. So the big R gonna be square root x minus 0, which is square root x. Does it make sense? For the inner radius, this is small r. So this is going to be from the axis to the small one, to the small one, to the small one. This is just small r. So that means the small r going to be x squared minus 0 equal to x squared, because it just starts from the axis of rotation, which is x equal to 0, well, to the y, which is y equal to 0, well, to the top curve, which is y equal to x squared. Well, once you have those two, outer radius and inner radius, you plug in here. So you're going to get pi times square root x squared minus x squared dx. And then what is going to be my limits of integration 0 to 1? How do I know that? For sure, this is 0, 0 to 1, 1. So x start from 0 to 1. And then the rest of the work is just integrate 0 to 1 pi x minus x to the 4th power dx. Well, you can integrate this thing easily. So you're going to get x squared over 2 minus x to the 5th power over 5. Evaluate at 1 and 0. And then you're going to get 3 pi over 10. Well, I did it fast because, you know, I have a solution in my hand, but well, actually you can integrate that. Just it's gonna take a few minutes for you to plug in, but yeah, that's easy. All right, any question on this example? Sounds good. All right, this is a case that we have the hole inside, so we're gonna do more examples. Let me see. I think we have 2 more examples, and then we start the shell method. So let's look at 187. So again, the hardest part for this chapter is, well, you have to figure out the picture first. So example 187, I have the region that is bounded by the curve here and the line here, all right? Well, pretty easy for me because we know that y squared equal to 4x. Well, actually y equal to x squared is parabola, right? But y squared equal to 4x, this is going to be the parabola again, but it's just, you know, different axis. It's gonna be that, right? This is y squared equal to 4x. All right, and then we have x equal to 1, which is that. Oops. Okay, x equal to 1. All right, so we just need the region bounded by this two curve, which is that. Well, did I record the lecture? Okay, I did. Good. Okay, good. All right, I have that. And then now the question asks us to rotate this region around the y-axis. So this is going to be my axis of rotation. So what should we do? So the idea is now you are trying to use the Watcher method to find the volume of the solid of revolution. So the idea is you have to cut perpendicular to the axis of rotation. So that means when you cut, the axis of rotation is here. So you have to cut the horizontal line because you need perpendicular to the axis of rotation. So cut perpendicular to the axis of rotation because we want to use the watcher method. So now you haven't seen the shell method. If you see the shell method, well, you can see that you can do two ways, either shell or watcher method, because shell method gonna cut parallel to the axis of rotation, but for the watcher method or this method, you're gonna just cut perpendicular. So we're gonna cut here as a horizontal line here. So, and the formula is gonna be V equal to integrate from something to something, pi big R square minus small r square, and then dy. All right, this is the formula. So what you have to do is you have to figure out outer radius and inner radius. So outer radius, big R, going to be something from the axis of rotation to the axis, right? Something from the axis of rotation to the axis, to the outer function. That is the outer radius R. For the inner radius, small r, this is going to be from this axis, and then you just go to the inner curve. So the outer radius are going to be 1 minus 0, which is 1. Does it make sense? Because x equal to 1 is on the right hand side, x equal to 0 is on the left hand side. So outer radius is 1 minus 0. Inner radius going to be the curve parabola minus 0. So what is the curve parabola? So it's y squared equal to 4x, which means x equal to y squared over 4, right? You have to just simplify first. So that means x equal to y squared over 4 minus 0, right? Because the outer curve is x equal to y squared over 4. The inner curve is x equal to 0. This is y squared over 4, right? And then after that, you integrate here. The big R going to be 1 squared is 1, R squared is going to be y to the 4th power over 16 dy. And then you integrate from, you have to find the intersection, right? That is your interval that you're going to cut the horizontal line. So what is going to be the interval here? So you have y squared equal to 4x. You plug in x equal to 1. So y squared equal to 4. That means y equal to plus or minus 2. All right, negative 2 to 2. And then you can integrate this thing by yourself. Well, let me do that. So it's pi and then y minus y to the 5th power over 5 times 16, 80. And then from negative 2 to 2. All right, and then you integrate that, evaluate that. So you get 16 pi over 5. This is your answer. All right, sounds good, everyone. So this is how you use the watcher method or this method, but you just integrate with respect to y. Good. All right, so I mean, if on the exam, if you see the question say use the this method or use the watcher method, so you have to use the this method or the watcher method. You have no choice. If I didn't, if the question didn't say anything, good, then you can pick whatever you want. But I think they're gonna force you to use this method one question, and then shell method one question. So you have to learn two method anyway. All right, let's move to the last one for this section, example 188. Well, this gonna answer previous question that he asked at the beginning. Let's suppose that we have the region R, which is what I highlight here. And then now we are going to rotate about the other line. For example, y equal to -1, x equal to 1 or something, whatever. So let's see how we approach this thing. So let's suppose that I have the region R2, which is bounded by y equal to x squared plus 1 and y equal to square root x plus 1. So this is the region R2. Now, the question said that what is going to be the volume of the solid if you rotate R2 on the interval 0, 1, and then you rotate about the axis y equal to -1. So here is the axis of rotation. Here's the axis of rotation. So, well, the idea is the same. So you need to do v equal to integrate from something to something pi the big R square minus small r square dx. And then you can see, oh, well, first of all, how do I know that I'm going to use dx? Because the axis of rotation is here. And then because you choose to use the Watcher method, that means you have to cut perpendicular to the axis, which is going to give you dx. Does it make sense? First, you need to figure out dx or dy. So once you know that you're going to use dx, good. That means we're going to draw the vertical line. And then now to figure out the inner and outer radius. So the axis of rotation is here. Then I highlight in green, right? And then you can figure out that, hey, what is going to be my outer radius? So my outer radius is going to be from the axis to what? To the outer curve, right? That is the outer radius. It's going to be here to that, here to that, right? The red line, the red vertical line that I just drew, that one is the outer radius, which is going to be the outer curve square root x plus 1 minus the bottom curve, which is y equal to -1. So the outer radius is going to be square root x plus 2. Good. So the inner radius, all right, I need more space. So going down, all right. The inner radius, small r, inner radius. Well, you can see from the picture now that the inner radius is going to be this curve, the one that I highlight in yellow. This is going to be the top one for the inner radius, right? That means now you do the x squared plus 1 and then minus -1, because -1 is your bottom curve, and that is x squared plus 2. And then the answer for this question is going to be integrate pi, and then you plug in r, which is square root x plus 2 square, and then minus small r, which is x squared plus 2 square. And then dx, x from, well, we need to find the intersection. X from where to where. So for sure, you can see from the picture that it starts from x equal to 0. So what is going to be the intersection here? The best way to do the intersection is you eyeball it. So you can see that because you know what, if you want to set square root x plus 1 equal to x squared plus 1 and solve, you can, but it's just slow because you have to, you know, square and then doing some algebra. Well, you can see that, hey, the intersection here, it's just x equal to 1, y equal to 2, I think, because if you plug in x equal to 1, you get y equal to 2, which is good. That means x gonna be from 0 to 1. That's it. Well, actually, you need to integrate, right, to find the exact value. But for this question, I'm gonna stop here because this is what are we going to test you on the exam. So we do not want you to evaluate. We just say that you set up and stop. So the question on the exam gonna say set up, but do not evaluate. So the same thing here, evaluate. So that means, well, once you get up to this point, you stop full credit done. Does it make sense? For this chapter, we do not want to test you something ridiculous to, expand and make some mistake, well, just once you set up, you're done. Just for this chapter, and it's gonna state on the exam that set up but do not evaluate. So fine. Well, any questions so far? Well, we're gonna do one more example and then we're gonna answer the questions. All right, the same example, but this time I'm gonna rotate about the vertical line. So let's say that, well, I have the same example as before. So I have fx and gx here. And now I'm gonna rotate by using the x equal to 2 as my axis of rotation. So this is what happened. So because you're gonna use x equal to 2 as your axis of rotation, and if you choose to do the disc or watcher method, so the idea is for sure you have to use the horizontal line, because you're gonna cut perpendicular to the axis of rotation. That means when you do v equal to integrate pi big R square minus small r square d, you have to use dy, because you're gonna do the horizontal line. And then well, from A to B, well, we have not figured out the constant yet, so we're gonna start by looking at the outer radius, which is going to be from the axis to the outer curve, from the axis to the outer curve, from the axis to the outer curve. Well, the right hand side is going to be number 2, right? It's x equal to 2 is the right hand side. The left hand side is actually it is y equal to square root x plus 1, right? Y equal to square root x plus 1, but you need x in terms of y, so it's going to be x equal to y minus 1 square, right? That means the outer radius is going to be 2 minus y minus 1 square. Does it make sense? Because the right hand side curve gonna be x equal to 2. The left hand side curve gonna be x equal to y minus 1 square. And then now the inner radius. The inner radius gonna be from the axis to the inner curve, which is the number x equal to 2 again, minus something here. You have y equal to x squared plus 1. Well, for some reason you have to switch it to x equal to something in terms of y. So it means x squared equal to y minus 1, and that is x equal to square root y minus 1. All right. And then after that, you just plug in everything. So it's going to be pi times big R, which is 2 minus y minus 1 square. And then square. This is r square, right? And then minus small r square, and then dy. Integrate from A to B. So what is going to be here? Look at the intersection. So x equal to 0, y equal to 1 here. This thing is x equal to 1, y equal to 2, right? We just did on the previous question. So y going to be from 1 to 2. Sweet. All right. That is my answer. Well, if you want to integrate, you can do it at home. This is 31 pi over 30. Well, but who want to integrate this thing? It's ridiculous. And then the previous one, if you want to integrate 49 pi over 30. Well, I already did, but don't waste your time doing the integration, because if you can set up, well, you're good for this chapter. All right. Anything else for the watcher and this method? So we'll leave the question in the chat if you have anything. Any question? Because we're going to move to the shell method in a minute. And then, well, that's the last heavy content for this chapter. All right. Okay, any questions, students? All right, 30 students here. Any question? No? Do we have to evaluate the value in assignment 6? Question from Pimapon. The answer is yes, because on the assignment, you have time to do it. But on the exam, you don't have time to do it. Question from Pirisud. Why do we pick x equal to y? X equal to square root y minus 1. Why don't we pick x equal to negative square root y minus 1? Well, because you can see that what we have here is y equal to x squared plus 1, right? And we pick x to be positive because we consider something on the positive side of x, right? Actually, if you draw the graph y equal to x squared plus 1, you're going to get the smile here, right? Because the graph going to be on both the negative side and positive side of x. But because you just cut and just focus only on the positive side, so yeah, I mean, y is equal to x squared plus 1. But if you write x in terms of y, you have two equations. On the left-hand side of y-axis, it's going to be x equal to negative square root y minus 1. On the right-hand side of y-axis, it's going to be x equal to square root y minus 1. That is y. Sounds good? All right, hope that answered your question, because yeah, that is the basic properties of graphing functions. All right, good. If everyone is good, now we're gonna move to, well, the shell method. Well, be patient. This is the last content that is hard, and then after this one, it's gonna be just formula, and then we are done with this course. So you have next week to study. And then, you know what, we're going to finish the shell method today, and then next week we're going to learn arc length and chapter 8, which is going to be the small one. Arc length and chapter 8 we can do it in 40 minutes, and then next Monday we're going to sum up the what you have to focus on the exam. For sure chapter 8, because we just teach you for 20 minutes, so it's going to be just only one small question, that's all. So the focus on the final going to be chapter 5 and 6, as I told you, because you have time to study. Chapter 7 as well, but it's 20%, just less important compared to chapter 5 and 6. Well, the content is hard, I know, chapter 7, but because we just learned today, so it's not fair to test you everything super hard thing on chapter 7, because you don't have time to study it for sure. Let's see this chat. Okay, yes, chapter 8 is next Monday. Well, we just learned, and then we just learn to do the basic improper integral, and then we're gonna ask you simple one on the exam. I promise for sure. All right. Well, let's do the shell method. So, well, as I told you, this is the last hard part for the final exam. So the shell method is the idea that you can compute the volume again, but this time you're trying to cut parallel to the axis of rotation. What if you cut parallel the axis of rotation? What are you going to get? So let's look at the picture that I circle here. So let's suppose that you have a solid like that I focus here in, that I just circle here. So you can see that one way you can do is you can cut, and then you're gonna get this circle with the hole inside, right? That is the one way you can do the computing the volume. That means you use this method. Another way you can do is you're gonna use the shell method. So the shell method means you cut parallel to the axis of rotation. And that means what you are going to get is you are going to get the cylinder with different radius. And once you get all cylinder with different radius, and then you just group it together, that is going to be the solid, right? And this is going to be a good way to compute the volume because, well, you're going to start from split your solid into n pieces, but you're going to split the solid into n cylinder, right? And then for each cylinder that you have here, you're going to unfold it. Once you unfold it, you're going to get the box, something like the, the rectangle. And then you can compute the height, compute the length. So you get the area. And then you multiply the thickness. And then that will give you the volume for just one cylinder here. Just the one, one cylinder before you unfold. And then after that, you're going to get this thing so many times n pieces. And then you take limit when n go to infinity. So this is that formula. And then because limit of summation, again, continuous sum mean integration. So it's going to be integrate from a to b times the height and the length. All right, so we're going to look at the theory first. This is the idea. So the theory said that, so let's look at this picture together. So you have the region R, right? And let's suppose that the axis of rotation is Y. This is the axis of rotation. Well, for some reason, you feel like, Ajahn, we want to cut parallel to the y-axis because it's easier. You can see if you cut perpendicular, it's hard because you have to split the region. So, well, for some reason, we would love to cut parallel to the axis of rotation. So you can do that, but you can see that for each line that you cut parallel to the axis of rotation, if you rotate it, you're going to get a cylinder. Well, for each cylinder that you have, you can compute the volume for that cylinder, which is going to be here, going to be your height, right? And your length, it's going to be the circumference here after you unfold it. So I have a better picture next slide, but well, let me talk about the idea first. And then after that, well, once you do compute the volume for each piece, and then you group it for all n piece, and then you take limit, well, that will be integration. So to compute the height and the length here, the length of the, after you unfold. So let's look at this picture. So you have here, and then you unfold it. So this is going to be your height. So your height going to be fx, right? Fx in terms of, if you have this thing is your function f, if you have this thing in terms of 0, so fx minus 0, this is going to be your height, which is that. And then for your length here, it's going to be 2 pi x. Where does it come from? It's come from here. Here. You have the radius r, right? And then you just unfold it. So that length is going to be the circumference, which is 2 pi times radius. So it's actually 2 times 2 pi and then time radius. But your radius is x here because the axis of rotation is y-axis. And then, you just measure from that point, which is x, to the axis 0 here, which is going to be x minus 0, which is 2 pi x. So actually, this is a formula for the shell method. So integrate from a to b, 2 pi x times fx dx. Well, my suggestion, this is my suggestion. I do not memorize the formula as a 2 pi x fx dx because it's confusing to me. So what I memorize is I memorize this to be integrate from a to b 2 pi times shell radius. This is make more sense to me times shell height. It means every time, and this can be dx or dy, it depends on you. But this means every time when you want to use the shell method, you have to figure out what is your shell radius and what is your shell height. Once you get this two, then you just plug in into the formula 2 pi shell radius and then time height, and then dx or dy depends on you, because you have to cut parallel to the y-axis. All right, I know this is looks complicated to you, but well, you will see that this is a lot easier compared to Watcher method. I love this method so much because uh, it's beautiful. All right, let's look at the example together. Here. This is what I just told you, that what I memorize, I do shell radius times shell height. Well, but it's up to you. I mean, if you feel like, Ajahn, I feel like it is better to memorize 2 pi x f x dx, it's up to you. But well, this is the general way to memorize. And then if I move the axis of rotation to some other line, not x-axis or y-axis, your shell radius is going to be different than x or y. And if you just memorize the previous formula here, it's going to be terrible, because you have to fix your formula all the time, because your radius can be something else other than x and y. Well, you will see it. Well, let's talk about the example so you see the more conceptual idea about this thing. So example 190. So this is going to be your first example about the shell method. So we want to find the volume of the solid obtained by rotating about the y-axis, the region bounded by y equal to 2x squared minus x cubed and y equal to 0. This is the one that you cannot draw it by hand. So if the graph cannot be drawn by hand, we're going to give it for you. And this is the graph y equal to 2x squared minus x cubed. Actually, you can draw it by hand, but it is not easy, right? Because you just need to use a technique from chapter 5 to draw it, which is ridiculous to do it here. So we're going to give it to you. And then for this one, we're going to rotate about the y-axis, which is the axis of rotation here. So, well, you can see that the easy way to do the volume of the solid obtained by rotating the about the y-axis is you have to cut the vertical line. Why? Because if you do the horizontal line, what the heck, right? So the right hand side curve going to be this one, the left hand side curve going to be this one, and because you have y equal to 2x squared minus x cubed, what is going to be x in terms of y? You're going to say no, right? How can you just switch this function into x into some function of y, and you're going to do this minus this? No way. This is way too hard. So some question it force you to do like this question, it forces you to do the line parallel to the axis of rotation. That means you have to use the shell method. So the shell method means, well, once you cut here, so every x value you cut, you're going to get the cylinder. Well, but just keep the picture clean. We're going to just cut at 1x, and then we have the cylinder here. So the volume going to be integrate 2 pi shell radius times shell height. And then because you cut vertical line, dx, good. And then now integrate from what to what? Well, integrate from actually 0 to 2, because you have here, because you can draw the vertical line all the time here, right? So it's going to be 0 to 2. All right. So, but keep the picture clean. So I'm gonna just say 0 to 2 here. And then after that, well, what is going to be your shell radius? So let's figure out the shell radius. Shell radius is going to be here. Wow, easy, x. Well, the shell radius gonna have something different than x when you move the axis of rotation to something else, not the y-axis. We're gonna have examples soon. Let's suppose that I move the axis of rotation to x equal to -1. Then the shell radius is gonna be x plus 1. So the shell radius, usually it is x, but if you move the axis of rotation to something else, well, you have to figure out again. So for this question, easy, x. And then for shell height, it's going to be this line, which is going to be, hey, easy. The top one is 2x squared minus x cubed. The bottom one is 0. So good, the x. All right, so well, I have the answer here because I'm lazy to integrate, but you can integrate this thing at home. Well, 2 pi integrate 0 to 2 2x squared minus x cubed bx. This is the easy one. Well, as I told you on the exam, we are not going to ask you to integrate this thing. Once you are done up to this point, you're done. But here, because you have time, this is in class. So 16 pi over 5. So you can stop here because on the exam, they're going to say set up, but do not evaluate. So that's fine. But sounds good. All right. So any general question about the shell method? Anything? I think we have, well, let's see how many examples do we have of shell method. So we have few examples of shell method. I think 3 examples. So we're gonna keep going. And then after we're done with all example with shell method, we're gonna stop. And then next Monday, we're gonna continue arc length and improper integrals. One question from Pawin. He asks us that how can I know that the integral is from 0 to 2? Well, the 0 to 2 here gonna come from what is the interval that you have to draw the vertical line, right? Because for each x value here, you're gonna get one cylinder. So, and then you sum the cylinder all together. So that means we have to figure out what is going to be the region and what is the x value that we have to draw the vertical line with respect to, which is start from 0 to 2 here. It is given for this question. You do not need to find the point of intersection. Did x from the radius just missing or I missed something? So the radius here gonna be x because this is x. This is 0 to x, right? 0 to x. Your x here, this is actually the variable, but it just fixed after you fix at one point. Once you fix at one point, it's going to be x, right? And no matter what cylinder, where cylinder is, so this at this point is going to be x anyway, and then your radius is going to be x minus 0 anyway. Does it make sense? Well, I know this is your first example, so it's going to be a little bit confusing for some of you, but the last integral. Oh, okay. Yes, that x too. Sorry. Thank you. Well, good job. Yeah, just x again. Well, I just added. All right. Anything else? All right. Thank you. Who said that? Puri, right? Yes. Thank you. Yeah, I missed one x here because I just copied it wrong. So I just copied from the previous slide, but I did it wrong. All right. Yeah, 2x cubed minus x to the fourth power that is correct. All right, we are going to look at example 191. All right, so for those of you who want to stay practicing shell method with me, so I need 15 to 20 minutes more. All right, sounds good. Example 191. All right, so we have the graph here, y equal to square root x minus 2. Well, I told you this is the candidate for this graph. It just show up all the time on the exam. So if you don't know how to graph y equal to square root x, you screw. I told you, practice that one. So y equal to square root x is like that, right? But this time you're going to shift to the right hand side two times, I mean 2 units. So you're going to get x, minus y equal to x minus 2. And then after that, hey, y equal to 2, simple. All right. And then read the question again. We need something on the first quadrant and then bounded by this line and this line. So it must be this area. All right, sounds good. And then after that, what is going to be my axis of rotation? X-axis. So it's going to rotate about the x-axis. All right, good. And then after that, here we're going to use a shell method. So we're going to draw the horizontal line, right? Because we're going to draw the line parallel to the axis of rotation. Well, if you do not want to get confused about the Washer and shell method, just memorize shell method mean cut the line parallel to the axis of rotation. This method or Washer method mean cut the line perpendicular to the axis of rotation. This is what I memorized when I was a kid. And some of you read Pitun sheet, and Pitun sheet just say this thing too. So this is a technique that you use all the time, and you will never get confused about this method, Washer method and shell method. All right. Here, this is going to be my this is going to be my horizontal line. So we are going to well, 1 second, we're going to set up. So I lost what I'm going to say. So we're going to set up the integral. So integrate from a to b again, 2 pi times shell radius and shell height. All right. Very easy. And then you have to do dy here because now you are going for horizontal line. So what is going to be your shell radius and shell height here? So, okay, at this point, this is y, right? At this point, this is y. So you're going to say that, hey, this is y equal to 0, the axis of rotation. So the difference between the axis of rotation and your fixed value y here going to be your radius, which is y. So you can imagine that you have the cylinder here, right? So the axis, the radius are going to be y minus 0, just that one, the vertical line that I just drew. But the shell height going to be here. This is shell height, right? And this is going to be your shell radius. Does it make sense? So your shell height going to be what? So it's going to be the right hand side curve, which is y equal to x, y equal to square root x minus 2. And then the left hand side going to be x equal to 0, right? Well, you have, that means you have to convert this thing. So you're going to convert this to x equal to, well, let's go slow, y square equal to x plus 2, which means x equal to y square. I did it wrong. Do it again. So it's y square equal to x minus 2. So that means x equal to y square plus 2. Good. So that means your shell height gonna be y square plus 2. This is the right hand side curve. And then minus the left hand side curve, which is just the y-axis. So x equal to 0. And then dy. All right, so you integrate from a to b. So what is your a and b here? So what is going to be the horizontal line that you have to draw? You have to draw all the way. So that is going to be y equal to 0 to y equal to 2, right? Because you have to draw the horizontal line from y equal to 0 to y equal to 2. And then for each fixed value of y, you get one cylinder. And if you keep doing that for the whole interval 0 to 2. So you get the solid. Well, the answer is here. Well, you can stop here if you want, but here, if you keep doing it, it's going to be 16 pi. All right. Well, you can stop me anytime if you ask something in the chat. I'm going to answer that. If you don't have any question in the chat, I'm going to keep going because I think we can do up to. Well, I think we can do 2 more example and then we can stop. Here, this is a picture, yeah, for the previous question. So you have the region R here, and then you rotate about the y-axis. So this solid that you're gonna get is going to be this one. And then you can see that we compute the volume of the solid by just compute the volume for small cylinder here first, and then you keep doing it. Just different cylinder with different radius, and you keep doing it until you're done. Good. This is called the shell method. All right. Let's do example 192. All right. This is the interesting one again, because now we are going to look at some problems that you need to rotate something about something different than x or y axis. All right, so let R be the region bounded by this graph. All right. Okay, let's draw it first. Y equal to e to the x. Good. X equal to 0. Good. X equal to 1. X equal to 0 is y-axis, right? And then y equal to -1. And then x equal to 0. X equal to 0. All right, so we have here. Oh, looks pretty easy to me though. The the region looks pretty easy to me. So, all right. So the question forces you. You see, the question forces you use the shell method to set up, but do not evaluate an integral you would use to find the volume of the solid generated when I is revolved about the y-axis. So the first question gonna be this region are gonna be rotate about the y-axis. So because, well, part A, because you want to use the shell method. So this means you have to cut parallel to the axis of rotation. Well, once you want to cut parallel to the axis of rotation, that means you have to cut the line, vertical line, which means when you do V, it's going to be integrate 2 pi shell radius times shell height. And then it's going to be dx because you cut vertical line. So what is going to be your shell radius and shell height? So your shell radius going to be, well, let's say A to B first. Shell radius going to be the one. Well, to keep the picture clean, you can think of just 1x where you here. And then you can imagine that after you rotate, you're going to get a cylinder. So the shell radius gonna be just x, right? Because at the fixed value x here, you have x here, fixed value, and then you're gonna find the difference between, you mean the radius here, difference here is just x minus 0, which is x, right? You can just say x, x, this is your shell radius. And then your shell height gonna be here, this is your shell height. For sure, this is e to the x because it's the top one minus the bottom one, which is y equal to -1. And then integrate from 0 to 1. How do I know that? Well, because you have to draw the vertical line from 0 to 1. X equal to 0 from x equal to 1. So to set up the integral, you're gonna get 2 pi time integrate 0 to 1 x e to the x plus 1 dx. All right, full credit, good. Sounds good. All right, so let's do what happened if I switch my, well, the part B question. The question is the same, except the last part I say, let's move the axis of rotation to x equal to -2. So what happened? So if I move, wow, I need one more page, I think. So if I move, well, let's draw a picture first. Let's draw the picture first. Okay, y equal to that, e to the x. And then I have x equal to 1, x equal to -1, y equal to -1, right? And then my region is here. One more time. And then now you can see that, well, this time I have this line, x equal to -2. This is going to be my axis of rotation. It is here. So what is going to be my v? For sure, this is going to be integrate 2 pi shell radius times shell height and then dx, right? Because you still do vertical line here because you need parallel to the axis of rotation. And then now what you need is now your cylinder gonna be something bigger because your radius gonna be a little bit bigger because this is your axis of rotation. So your radius here gonna be a little bit bigger. This is your radius, right? But your height is going to be the same. So your height same. So your height gonna be integrate 2 pi, well, radius we're gonna come back with radius, but height is gonna be e to the x minus 1 here dx. Well, same thing because your top curve for the height gonna be the same function. The bottom curve gonna be just y equal to -1. But your radius here, before you have just at the x value here, before you have the x value here to 0, right? The one that I highlight in light blue. But now you just keep going up to x equal to -2. This is actually your radius. So that means your radius is going to be x minus -2, which is x plus 2. So, and you integrate the same thing, 0 to 2, 0 to 2. 0 to 1, sorry. 0 to 1, 0 to 1, because x equal to 0 and to x equal to 1. This is the interval that I highlight in orange in the picture. All right, so we have 2 pi integrate 0 to 1 x plus 2 times e to the x plus 1 dx. How do you feel? Good? All right, so type in the chat then what is going to be your score for this and shell method? How confident you are out of 10? I want to see that. And then we're going to do one more example and then we can go. 8, 7, F. Okay. I know it's hard to learn something today and then you just need to do a test next week, but next week. But well, you know, sometimes you cannot choose. All right. So what are we going to do is we are going to do one more example, which is example 193. And then example 194 and so on. This is going to be on the clip. So let's do this one. I'm gonna make the clip for you on my YouTube channel so you can, this one is called, well, I'm gonna say this is a practice problem. So you can do it at home and then you can check with my solution in the clip. this one to practice problem. So can do it. Well, this one to practice problem. All right. Uh, well, actually, well, we'll see, but well, today we're gonna stop at example 193, the last one for today, and then the remaining slide, I think we're gonna do on the clip that I'm gonna post soon on Friday. I think I have not recorded, but I have a plan to do that. All right, so let's do example 193. So I think you are tired for today, so let's do one more and then we can go. All right, we have the region here, which is the one that I already draw it for you. So the question say that can you use the shell method to find the volume of the solid generated when R is revolved about the line x equal to negative 1/2. All right, that is not that hard. So we have y equal to 1 here, y equal to square root x here, and y axis here. So we have everything. Good. V is going to be integrate. So first of all, well, if you want to use the shell method, well, you figure out the axis of rotation first, which is here, right? X equal to negative 1/2. This is the axis of rotation. So when you have the axis of rotation here, so that means you can you want to use the shell method. That means you have to draw the line parallel to the x-axis, parallel to the axis of rotation. Well, that means you have to do dx. It's going to be v equal to integrate 2 pi shell radius times shell height, and then dx. And then you're gonna integrate 2 pi. What is your shell radius here? So, well, let's see. If you want to make it clean, so you can just pick one thing here, and then you get a shell. Right? You get a shell here, and then, well, this shell is not in proper scale. It should be something a lot bigger because the center is here, right? And then your radius gonna be this one. The line, the the orange one gonna be just the radius. So when you just fix the x value, you fix the x value. Well, the radius gonna be x. You measure the difference from x here to the x at negative 1/2, right? So it's gonna be x minus negative 1/2. Does it make sense? And then for the shell height, it's going to be that shell height. But this time, the top curve and bottom curve, they are bounded by different curve. So the top curve going to be y equal to 1. The bottom curve going to be y equal to square root x, right? This is the top curve. This is the bottom curve, shell height. And you can see that for every vertical line that you're trying to draw, so it's going to be the green one to the light blue, the green one to the light blue all the time. So this is going to be your shell height, dx. Well, x from where to where? So it's going to be x from 0 to the intersection here, which is going to be 1, 1, right? Because you just plug in y equal to 1. So 0 to 1. All right, and that is 2 pi integrate 0 to 1 x plus 1/2 1 minus square root x dx. All right, so I'm lazy to integrate, but well, you can stop here. Well, just add that, just set up, but do not evaluate. Because the less of the work, it's just easy. All right, any questions, student? So it's 4:16 now. I think you are tired. I am too. So any question in the chat, please? So let's see. People are going to say 8, 7, 8, 7, 10 for the effort. Well, if you say 9 or 10, well, I wish you get 9 or 10. So I memorize your name now. So well, which you get good score on the exam. So well, you can do it. This chapter is not that hard. All right, any question, guys? So again, I'm gonna post a clip pretty soon, and the the record tutoring from TA, I have not heard back from them, but once I heard back from them, and then I get the link, I will give it to you immediately. But well, I asked them this morning, but they haven't sent it to me. So well, we'll see, but that must be pretty soon, I believe. And okay, one more good news. So we're gonna give you double angle and what is it? Double angle formula and half angle formula on the exam. So you do not need to memorize those two trigonometric functions. So well, this is the good news for you. So let's do that. So good news. So one more thing. Good news for you. So for those of you who practice trigonometric function now, so this formula sine square equal to, well, even me, I cannot memorize 1 minus, no, yes, I think this formula, right? This is right, and that cosine square is that. This is given on the exam. So you don't need to memorize. And also this one, sine 2 theta equal to 2 times sine times cosine. And then also cosine 2 theta. This is cosine square minus sine square. This one also given. So this is called the double angle formula, right? This is called the half angle formula. This 4 formula will be given on the exam. So you do not need to memorize. This is given on the exam.